All right, so we are going to do a new lesson today, and it's called Distances and Midpoints. We did this in geometry last year. I'm going to go through relatively quick, but we'll try to get through them both. I think in geometry, I think I split it up. One day I did distance, the next day I did midpoints, but I think you guys can handle going a little faster. So, it's too much?
Yeah, I was going to say that too.
All right, let's do this. Hopefully, you'll recognize some of the stuff that we talk about. Let's call that 0, 1, 2, 3. Call this -1, -2, -3. All right, and let's put a point on one of these coordinates. Let's put a point right here. We'll call it point A. Let's put a point right here, and we'll call it point B. All right, and so what if I asked you to do this? Let's go back to whites. What if I asked you, and this is kind of a geometry thing. What if I said find AB? What does that mean when I just say find AB and that's all I say? Find the distance. Very good. Find the distance between A and B. That's what it means. Everybody see that? They don't put the words find the distance, or they don't put the words find the length of. All right? They just say find AB with nothing over top of it. That means find the length of it. You could do this a couple ways. You could just count, couldn't you? Small enough, right? There's not too much to count. So you could count. Start at A and go to B. So let's count. Ready? 1, 2, 3, 4, 5. So you could just say it's 5 because I just counted, right? There's a better way to do it, though. I mean, that was an okay way to do it if the graph is that small. But what if I had a graph? What if I said that one point was down here at -716 and another point was over here at +1,243? I'm being ridiculous, but you get the idea. Are you going to sit there and count -215, -214? No, that'd be ridiculous. So exactly right. So what's another way to get a 5 out of a -2 and a 3? Okay, you could go to here. How many is that? That's 2. How many is it from here to here? That's 3. But it's really not addition. You're not really adding because this is a -2, right? So what's -2 plus 3? It's +1. Is that the distance from there to there? No. So it is not addition. What is it? Subtraction. And watch what happens. Does it matter which order you subtract them in?
Yes.
Well, it doesn't if you do something. I'll show you in a second. Let's just go for A and B. So let's go -2 minus 3. What is that? Now, when I ask you to find the length of something or the distance, yes, you got it. When I ask you to find the length of something or the distance of something, I would not measure. If I got a tape measure right there. If I was to measure the length of this whiteboard or something, okay, I wouldn't say, oh, that looks like it's -7.5 feet. Would you? No. You would just say it's what? 7.5 feet, right? So from here to here, you wouldn't say it's -5 inches or -5 centimeters. You wouldn't, would you? What would you say? It's just 5. So how do you get a 5 out of that? Okay, you just make it absolute value, all right? A lot of people freak out about this, but really it's just saying take the positive version of the subtraction. Everybody got it? So you can subtract, and it does not matter what order you subtract them in, as long as at the very end, what do? You just make it positive, okay? So I could have subtracted the other way. I could have done what? 3 minus what? -2, all right? Put it in absolute value. 3 minus a negative, that's the same as 3 plus. Some people are thinking, Mr. Hamrick, I thought you said you're not adding. But, I mean, technically you're adding right now, but were you adding at the beginning? No, it was a subtraction problem, all right? So this is what? 5. It's already positive. You don't even have to worry about the absolute value. All right, and it just equals 5. It equals 5. Either way you do it, okay? So if I just didn't even give you a number line, and I just gave you 2 numbers that said find the distance between them, that's what you would do, all right? Let's do this. Now, that was pretty easy because we're just going across. Okay, you could do the same thing going up and down. I'm not going to do the whole thing, but I will just show you. What if you're going up and down, and this was -7, and up here was +3? Okay, how far is it from -7 to +3? Well, what do? How do you figure it out? You subtract. It doesn't matter what order. Okay. Normally, to get a positive answer, I would take the bigger number minus a smaller number. All right. But it doesn't matter what order. But let's do it like that. 3 minus what? -7, which is 10. It's already positive. So what's the length from there to there? Oops, that was awful. Okay, that would be 10, wouldn't it? Everybody with me? Okay. So now what we're going to do, we're going to put it all together. Let's just do this, and what I'm going to do is put a line segment on here. So it's not horizontal, it's not vertical, it's kind of at a slant. Okay, what if I wanted to find the distance between this point right here and this point right here? I don't know, maybe some of you guys already remember the distance formula. You did it quite a bit last year. Well, not quite a bit. You did it a few times last year, so I don't know if you remember or not. Or actually, you did it. Yeah, you did it last year. Yep. Yeah, it's the thing with the square root. Very good. All right, but let's go through it quickly, okay? I'm going to go kind of fast because this should be old news to you. This point right here, we'll call it our first point, so it's an ordered pair. So if I call it my first point, I'm going to call this what? X1, Y1. If this is my second point up here, what am I going to call that? X2 and Y2. All right. Problem is, I can't just subtract this point from this point to find the distance because I'm not just going horizontal, I'm not just going vertical, correct? So what I'm going to do is this. Let's make a triangle out of it. So let's take this to here, and let's take this to here. Now let's make that one a different color. There we go. Everybody with me so far? So, oops. Here's the trickiest part of the whole entire thing. What's that point right there? Is it going to be like X3, Y3? Now, I want to write it in terms of my X1 and my X2s and Y1 and Y2. So, how do I find that point? Well, I have to go over, then I go down, correct? How far over to the right did I go before I started going down? X2, good, because how far did I go over to get up to this point? I went over X2, correct? So I went the same distance to the right to get up here or down here. Yep, so this is going to be X2. How far down did I go from here to here? I went this same distance from here to here, didn't I? Which is Y1. Make sense? Okay, with that said, let's push this up just a tad. With that said, what we're going to do is we're going to find the distance along the blue. Why? Because it's horizontal. We already talked about how to do that. We just subtract it, correct? And then we're going to find the distance of the green. That's vertical. We already did that. Then we're going to put it together. We're going to do something that we learned back in geometry again. You'll see what I'm talking about. Let's do the blue one. So I'm going horizontally. So which points am I going to use? The x's. That's right. I'm going along the x-axis. So how far is it from here, to there? That blue length right there, how far is it? I just subtract them, right? So what do I subtract? X2 minus what? X1, good. Everybody with me on that? Let's do the same thing with the green one. We're going up and down this time, right? So what am I going to use going up and down? I'm going to use the y's. So I'm going to go y2, what? Minus y1. It doesn't matter what order you subtract them in, okay? As long as you use the positive version. And I'm going to show you something in a minute that will guarantee that length is positive, all right? Now, I don't just have any kind of triangle. I drew this horizontal, I drew this vertical. So what kind of angle do I have here? It's a right angle, okay? So what kind of a triangle is this? It's a right triangle, all right? So if I know, I'll tell you what, let's put this down here. So it's on the outside, okay? So if I have a right triangle and I know two sides, I kind of know two sides, right? One is x2 minus x1. The other one is y2 minus y1. So I kind of know both sides of those triangles. How do I find the red one? How do I find the hypotenuse when I have a right triangle? What's it called? It's a certain... Yeah, but what's it called? What's it called? Pythagorean theorem. Good. So let's spell it right. Pythagorean. See, you thought that was over. It'll never be over in your math career. Pythagorean theorem. It occurs a lot. So Pythagorean theorem. All right, some of you guys are saying it to me already. A lot of times we remember it as a squared plus b squared equals c squared. I'm going to write it a little bit different, so that would be our c, wouldn't it? All right, actually, what I'm going to do is I'm not even going to make that c. I'm going to make it d. Why do you think I use d? D for distance, okay? So I'll use d, is that all right? Because we're going to come up with the distance formula. That's what I'm doing right here. I could have just started class and say, okay, here's the distance formula. Boom, there it is. But I think it's good for you guys to see where it came from. I did this to you with you last year, all right? And I don't know, is any of this coming back to you? All right, so watch. Let's just do Pythagorean theorem. C squared equals what? A squared plus b squared. Okay, well, generally. In general, we always use a, b, and c, all right? In this particular situation, I'm going to use d for distance, okay? So this is going to be the distance, what? Squared equals, what's the a? Really doesn't matter, but we usually do the x first, okay? But what are we doing with that x? Squaring it. Remember I said just a couple minutes ago, we're going to guarantee that that comes out to a positive number. What guarantees that that comes out positive? Not the absolute value, but the squaring, right? Because you square anything, it's always going to be positive, correct? Okay. And then plus what? Yep, y2. See, I keep clicking that button on that pen. y2 minus y1. There we go again. I did disable it, but it still jumps though when you push it. But anyway, we're almost there. We are almost there. Okay, let's write it, but let's not have d squared. Oh, I forgot. Yeah, you're right. I forgot to put this squared. Yep, thank you. All right, so now let's look at this. I don't want to write this as d squared equals something. I want d. I want distance. Okay, I just want d by itself. So d equals, how do I get d by itself? How do I get rid of that squared? Square root. That's right. So if I square root this side, I have to square root the other side. So let's do this. Big old square root. And then what do we put in here? x2 minus x1 squared plus y2 minus y1 squared. And that right there is your what? Distance formula. That's right. So let's call it that. Let's call it distance. Oops, come on. Again, I got to get used to this. Distance formula. That's something that has to be memorized, okay? I'm going to ask for it on the quiz. I'm going to say find the distance between these 2 points, and you're going to have to know the distance formula. Okay, you don't have to go through all this mess, all right? All we did here, the only reason we did this is just to show you why this is this. Does that make sense? Okay? And I think it's good to see, right? Because a lot of times we see these formulas in math books, you're like, where'd they come up with that? Would you agree? You ever thought that before? Sure. Well, right here, this is how they came up with it, all right? And it's pretty simple, I think, right? It kind of makes sense, and that's how we did the distance formula. You mean a square root?
Yeah, I think last week you supposed to leave it for...
Yeah, well, we're in Algebra 2, so we're going to simplify the square roots, okay? You mean if it comes at... I don't think this is going to come out to a fraction. This is going to come out to a square root of something. Oh, for midpoint. We're not there yet. But yeah, midpoint, fraction's fine. Okay. All right, but on this one, I don't think you're going to get that. Let's do an example, then we'll do midpoint, okay? Did you have the distance formula memorized before? Probably not. It was a long time since you did that stuff, but I'll put it right there. So what's a good way to memorize this formula? Is to just sit there and stare at it for 20 minutes? Not a good way. It's a way, I guess. It's not a good way. When you're doing your homework, what should you be doing? Write it every single problem, okay? Don't just put it at the top and refer to it every time. I mean, that would work. But if you want to really memorize it, every single time you do a distance formula problem, I would write the distance formula out, okay? That will help you memorize it, all right? Do you have to do it? No, but if you want to learn it, that's the way you should do it. That's what I would do. All right, let's do an example. Yeah, it's not that bad. It's just Pythagorean theorem, isn't it? Just Pythagorean theorem, but one of them doesn't have the squared on it, and you just square rooted it, okay? Really, that's all it is. It's just the Pythagorean theorem. Okay, example 1. Find the distance. Now, they're not going to give you a graph or anything, but they are going to tell you 2 points. Find the distance, I'll just shorten that, between, that's my shortened version of between, is that all right? -4, 2, and 1, 7. All right, so there you go. I'm trying to finish this whole thing during this class period, so let's just do it together. If we had more time, this is the last thing that we did, I would let you do this on your own, but let's do it together. So first of all, I write down the distance formula. All right, x2 minus x1 squared plus y2 minus y1 squared. All right, and now we just put the stuff in. So what is our x1, y1, x2, y2? Well, let's say this is our first point right there. So what's the -4? That's my what? x1. What's the 2? That's the y1. This is my first point, so it's x1, y1. This is my second point, so this is going to be what? x2 and then y2. So basically, if you know the formula, it's just plug and chug, right? Just plug the numbers in and work it out, and you got a nice little answer, okay? What I like to do, I call this the shell of the equation or the formula, and now we just plug some stuff in, okay? So we subtract the x's. Does it matter what order we subtract the x's in? Does not make any difference, okay? I'm going to go 1 minus -4. Why would I go that way? Yeah, because you get a positive, all right? What about the y's? How would you subtract them? Yeah, and again, it does not matter. Now, slope's a different story, all right? But midpoint doesn't matter either. Now, remember, you are subtracting. So what is 1 minus, or minus a negative is plus? Let's do this in our head. 1 plus 4 is 5. 5 squared is 25. This is 5 squared is 25. Yes? Okay, and that's equal to what? Square root of 50. Now, they have not taught you about radicals. Okay, radical is a square root, right? Like if you had a third root, fourth root, fifth root, they call them radicals, right? We haven't really talked about square roots before in this class anyway, but let me give you a quick showing how I would do this. The square root of 50 is the same thing as 25 times 2. Now, it's also 5 times 10. Why did I choose 25 and 2? Because I can take the square root of 25, right? So, watch. We have a rule in algebra that says if these two are being multiplied and they're both under a square root, I can split them up under their own square roots. Okay, so I can make this square root of 25, and I can make this what? Square root of 2, and they're being multiplied. Yep. And so our final answer, this is the best way to write your answer, especially since this is an Algebra 2 class and not geometry. Last year in geometry, I was fine with you just keeping it square root of 50, all right? Even though they haven't taught this yet, we're going to do a lot with square roots and different roots, all right? But this is what? 5 square root of 2. That's the distance. No reason to change it to a decimal. Now, in the real world, if I wanted to find the distance between 2 points and I wanted to measure something out and I was going to cut something and build it, I don't look at my tape measure and say, oh, that looks like 5 square root of 2, right? That doesn't make any sense. So yeah, I would put that into a calculator and get me a decimal approximation, right? So I could actually measure it. But in math, we're going to keep it like this. This is the way we simplify our square roots. Okay, enough of that. A calculator could do that nowadays, yeah. 7.07, I did it on the calculator as well, is the answer for that. All right, now let's talk midpoint. Oh, what am I at here? Algebra 205, okay. All right, I got time. I think I can get this done. So now let's talk midpoint. We're going to go through the same kind of stuff. So I'm going to go a little faster than what I did on the distance. Let's go back to the number line. You might have remembered me talking about this last year. Remember I said you're on the road? You ever see mile markers on the road? Okay, so let's say, I'm going to make this pretty easy. What do you got, soccer? All right, watch the video, do the homework. All right, so what if you're at the 3 mile marker, okay? And you want to come up here to the 11 mile marker. We'll make it easy, okay? You with me on that? So you're in a car, you're going this way. What if you're going to meet somebody in the middle? All right, so where would the middle be? It would be right there. Oops, I knew that was going to happen. Why did I do it then? Okay, let's say you're going to meet somebody right there in the middle. What mile marker would you meet that person on the road? Where it? 7, okay? How did you get 7? Good, that's what I wanted to hear. He went 3 plus 11 and then divided it by 2 and you get 7. That's exactly how I would do it. Some people said, well, I don't know, they just kind of guessed a number that's halfway between 3 and 11, all right? And maybe that would work. Some people did this. Some people went 11 minus 3. What's that? That's the whole distance. That's the whole distance. What's 11 minus 3? It's 8. And if you go halfway, how far are both of you traveling? 4. Okay? 4 away from 3 is 7, and 4 away from 11 going this way is also 7. But that's too complicated. The best way to do this, to find the midpoint, okay, along a straight horizontal line, all right, is adding the endpoints together and dividing by 2. That's the easiest way to do it. So 3 plus 11 is 14, divided by 2 is 7, okay? Keep that method in mind because that's what we're going to use to do ordered pairs, okay? Find the midpoint of an ordered pair. Does that make sense? Okay, so we're not subtracting. What are we doing? We're adding, okay? To find the midpoint, you're going to add the 2 endpoints and then divide by 2. Everybody got that? Okay, so let's do what we did earlier. Let's draw a graph. Let's put 2 points on there. This time we're not going to find the distance between the 2 points. What are we going to find? The midpoint. So let's do that. So we can go a little faster since we're kind of used to this now. I'll even make it kind of go in the same direction and everything. What do we make the bottom? Blue? We're going to make a right triangle out of it again. So I went to about right there. This goes to about right there. Oops, I'm going to make that one green. All right. I think. There it goes. All right, so what I want to do, and actually with this computer program, click right there. There's the midpoint right there. That's what I want to find. I want to find that midpoint. See that point in the middle of the red? That's what I'm trying to find. Where is it located? So let's go to yellow. We'll stay color coordinated here. What did we call this point down here? X1, Y1. This point up here, we called it, X2, Y2. And this point right here, that would be what? We went across how far? X2, and then we went down how far? Y1. Okay? Now we're going to do kind of the same thing as what we did, except we're not doing the distance this time. We're finding the midpoint from this point right here to this point right here, the halfway point. Okay? How do we find the halfway point? Well, you take the 2 endpoints and you do what to them? Add them up and then divide by 2. So what's the midpoint? I'll put it down here. What's the midpoint of that? X1 plus what? X2 divided by 2. All right, that's how you find the midpoint of that one. Let's do this again. So now, that's the midpoint of the blue one, right there. And this is the midpoint of the green one, right there. So what is the value of this midpoint? How do we find the midpoint of this one? Well, we're going up and down this time, aren't we? So it's going to be y, and you could go y2 plus y1. It doesn't matter. I don't know. For some reason, I went 1 plus 2. So let's do the y1 plus 2. Actually, I don't need parentheses around this. I don't know why I did that. Come on. Here we go. Over 2. Do you agree? That's that point right there and right there. So check this out. If I take this blue midpoint and go straight up, well, I was off a little bit. It's pretty close. Let's say right there, okay? And then I took this midpoint and I went straight across. Again, I'm off a little bit. Let's look where I am. So the midpoint of this one straight up, the midpoint of this one straight across. Look where I am right here. So what is the midpoint of this red point right here? I'll put it in parentheses. What is it? It's x1, x2 plus x2 over 2, comma, right? Because it's an ordered pair. What? y1 plus y2 over 2. And that right there is the midpoint formula. Let's write it over here off to the side. The midpoint is. Now, remember, it's a point. You wouldn't believe how many people on a quiz or a test, I ask for the midpoint and they give me like just a number. They give me like the square root of 30, or in the other case, the square root of 50. All right? It's not. It can't be. A midpoint has to be a what? It's in the name. It's in the word. It's got to be a point. What's a point look like? A what? An ordered pair. Okay, so midpoint has to be an ordered pair. I'm saying it now, and I got people with their head down, and people are going to write it not as a point. And I'm going to get so frustrated because all I can think of is when I was talking about this, that your head was down on the desk. So that is your midpoint formula. Again, you got to memorize it. You got to know it. So let's do an example, and we will be finished. This lesson wouldn't have taken any time if I would have just given you the formulas and shown you how to do it, right? But I think it's important, don't you?
Yeah.
I mean, do you have a level of appreciation for where these formulas come from? Good. That's what I'm trying to do. All right, so example 2. It says find the midpoint. I'm just going to shorten this. They give a whole bunch of other words. Just find the midpoint. It says find the midpoint of the segment with endpoints at blah, 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 right? All these words. Find the midpoint between, on this line segment right here that connects 3, negative 3, 4, and 1, 9. Okay? So let's do it. Midpoint. Let's write down the formula. Again, just like I said with the distance, if you want to memorize the formula, write it down every single time you do a homework problem. All right, so let's write it down again. It's off the screen here, but it's x1 plus x2 over 2, comma, y1 plus y2 over 2. And there it is. There's your formula. So now let's actually put the numbers into the formula. I like to do this. I like to put over 2 first, over 2 first, and then I just add up the x's, add up the y's, and then you just simplify it. It's as easy as that. So let's simplify it. Add up the x's. Which ones are my x's? Negative 3 plus 1. Does it matter what order you add? No. In addition, it does not make any difference, okay, how you add them up. But you do have to add the x's. Don't add one x and one y together, okay? That would be wrong. Just add the x's together. What about the y's? Add those. 4 plus 9. All right, and let's simplify it. We can do this in our head. Negative 3 plus 1 is what? Negative 2. Negative 2 over 2 is negative 1. Let's add this up. 4 plus 9 is 13. 13 over 2. Simone, this is probably what you're asking. Right there. You can leave it just like that. It's perfectly fine. All right. If you wanted to change that to a mixed number, you could. But the only thing that could happen is you just get the wrong answer. You know what I mean? There's no benefit, at least in answering a quiz question or test question. There's no benefit to changing that to a mixed number. In real life, absolutely, okay? I mean, again, I don't measure something and say, oh, that looks like 13 halves. I don't do that, okay? I would say what? What would it be as a mixed number? 6.5, okay? That's if I measure something, I would definitely say that's 6.5, okay? But as far as we're concerned in here in a high school algebra class, it's perfectly fine just keeping it like this. Now, if it wasn't reduced, you should always reduce it. So let's say this was, well, I don't know. What if it was 8? No. Let's go 12 over 8. What if your answer came out to that? Would you leave your answer like that? No, you would reduce it. What goes into both of those? 4 goes into 12, what? 3. 4 goes into this twice. So you should write your answer 3 over 2 if you came out to a 12 over 8 or something like that. Make sense? But improper, I'm perfectly fine keeping it like that. I know that the elementary teachers, middle school teachers, they harp about changing an improper fraction, which is this, to a mixed number, okay, which is 6.5, right? They harp on that all the time. In fact, I've heard a lot of teachers say, you need to reduce it. Well, this is reduced. So them saying reduce it, they're trying to say, turn it into a mixed number, right? That's not reducing. And if your teacher wants you to turn it into a mixed number, I mean, it's good to learn. I mean, it's not a bad thing. I mean, if I was an elementary teacher, I would teach kids how to change that to a mixed number as well. But not in here. You don't have to. All right, just keep it like that. It's perfectly fine. Make sense? Any questions, comments, anything? All right. So you got a little lesson here, right? 5 to 12. Man, that's not very many. I should give you more. What's that? They are weird? Okay. I don't know. I don't have it right in front of me, so I can't tell. So it's page 95. Oh, really? So they're not exactly like the examples I gave? Why would they do that? Well, I'll let you think of it. I'll let you figure it out. And then on Monday, we'll go over them, okay? You guys are smart kids, right? You can think on your feet. You don't have to just regurgitate everything that I just give you, right? So it's good for you. All right, if the problems are a little bit different than this, it's good for you to sit and look at them, think about it, try to remember some of the stuff you did in algebra. But we did that stuff in here too, didn't we? Didn't we do perpendicular lines? Is that what they do on here? What's that? Oh, they give you 3 points? I forgot that. And the ones I gave you, 5 to 12, are the ones with 3? Oh, okay. Well, that's what I'm saying. The 5 to 12 are just kind of basic, right? Yeah. All right. Yeah, we didn't get to the 3-point thing. Okay. All right. Yeah, the 5 to 12 is the stuff that I just went over. Okay, you were saying opposite, though. You were saying... Oh, because the other ones are the 3. Gotcha. Okay. Yeah. Well, it's 3-dimensional. All right. And we didn't really talk about that. And I don't have it in my notes. I was going to do it. And I thought, I think I'll just stay basic and not do the 3D thing. It's really not that much more difficult. It's not really any more difficult than this. Instead of that, you'd have a z in there, and guess what the z part would be? Plus what? Z2 minus Z1 squared, right? So really, it's the same kind of thing. It's really not that different. But we haven't talked about it. We haven't done the 3 dimensions, but that's what it would be. But life is 3-dimensional, isn't it? Like if you had to design a building or something, you're not just doing everything flat in 2 dimensions. So 3 dimensions is absolutely important because that's what life's all about. But maybe we'll talk about it on Monday. We'll look at a couple of those.
How much is it to buy a new math book?
Buy a new math book? You lost yours?
It got stolen in the lockers.
And you never found it?